Hey everybody, it's Mr. Carr again. Today we're going to be looking at the next part of our unit. We're looking at 2.3, we call it day zero. We're going to do some factoring, but this is supposed to be just some review of our factoring. So first of all, what is factoring? It means we're going to rewrite some kind of a polynomial using multiplication. I like to think of it as this. We are undoing distribution. Okay, so a very brief example of that, if I just have like 2 times x plus 2 turns into 2x plus 4, that's my distribution. Factoring would be taking this and going back into that format. So one of the first things we do, which is kind of my example here, is we look for our greatest common factor, our GCF. This is a number or variable that all the terms have in common. So in a way, we could say what can they be divided by? Not dividing it out, we're not dividing out by that, but what could we divide out of everything? Okay. And oh, here it is again. That factoring GCF is very much like the reverse distributive property. Okay. So it's very much like that example there. So let's try some real fast. So our first one is factoring our GCF here. If I look at just the numbers themselves, 6 and 10, I'm trying to figure out what do those two have in common. 6 and 10, the largest number they have in common is a 2. So that means I'm going to factor out a 2. So what I like to do is I like to do this. Then I'll go back and look at my variables, x and y. Nothing in common there. So my GCF here is just 2. What happens, the way I like to think of it is 2 needs to multiply by 2 things here to make it look like this. So what are those 2 things? Well, to get 6x, this would have to be a 3x because 2 times 3x is 6x. For the 10y, has to be a positive 5y there. And that's it. So we're going to do the next one like that's going to be the same exact thing with 12 and minus negative 42. I'm going to see what can I take out of both, which is a 6. Yeah, I can take a 6 out, and there's no m in both of them, so we'll just do the 1. So it'll be 6 times, it'll be 2 is left over because 6 times 2 is 12. And then negative 7m. Okay, so we have 6 factored out of both of those. For the next one, start with the numbers 4 and 24. We can factor a 4 out of those. With x to the 4th and x to the 2nd, since I have x squared here, and I know I have more than the x squareds in the x to the 4th part, that means I can take out an x squared. That's always kind of a shortcut, I guess. It's always going to be the lowest exponent for lowest exponent for variables. So I can factor out a 4x to the 2nd power. Same thing as when I did earlier. I want to make sure that it's got to be able to distribute back out to the original problem. So there's a 4 and a 4, so I'm going to have a 1 here because 4 times 1 is 4. And then I have x squared times something gives me x to the 4th. These be x squared. 4 times 6 gives me 24. I'm positive 6 in this case. And then x squared times, well, nothing here. It's going to give me x squared. So my answer here is 4x squared times x squared plus 6. Same thing in the next one. Now, just to change things up a little bit, I'm actually going to factor out a negative 2 here because I could take a 2 out of both of these just to show what happens. Additionally, when I look at my m's, my lowest exponent is m to the 2nd. So I'm going to factor out negative 2m squared. So when I do that, I'm going to see that it's going to be, negative 2m squared times 1 gives me my original problem. Then I'm going to have a negative 4 because negative 2 times negative 4 is positive 8. Then m squared times m gives me m to the 3rd. All right. Our next step we did in this is factoring trinomials. So if they're in this format where x squared plus bx plus c, and notice that the number here in front is a 1. The shortcut of this is we're looking at what adds to the middle number and what multiplies to the final number. The reason why is, let me look at this, for example. If I do my distribution property, and I do it with x plus 2 and x plus 9, okay, multiplying this out, distributing it means I'm going to take x times x. So that's an x squared. X times 9 is a positive 9x. 2 times x is a positive 2x. And then 2 times 9 is an 18. Put my terms together and I get x squared plus 11x plus 18. Notice if I'm trying to turn this into this, where did these numbers come from? The 11, the 18. 18 comes from the multiplication of 2 times 9. That's where this is. 11 comes from the fact that it's 2x and 9x, but then they add together to get to this. So anytime we do these as like the shortest version of it, we're just simply looking for multiplying to that C term. Okay, what multiplies to C, what adds to B. So if I do that here, kind of just logic, x squared has to come from x and x. Positive 2 means it, and with a positive in the middle, means that's two positive numbers here. And for me to get a 3 in the middle, that has to be a +2 and a +1, because those are my factors of 2. Here, if I do the same idea with guess and check, I've got x times x is my x squared. I got a positive, so it has to be two positives here. Then I start thinking about, hey, what multiplies to a positive 10 and then also gets me 7? Because in this case, there could be more than one, because I could do 1 times 10, 1 times 10, 2 times 5. If I need to list them out, I can, just to get a feel for it. And the only thing that works here is 2 and 5. So positive 2, positive 5, because they add up here and multiply here. Next one. We already did some examples with this. Always look for a GCF. It makes it a lot easier. 2, 18, and 28, I can factor a 2 out. So it'll be x squared plus 9x plus 14. Then I'm going to go ahead and look for what can I split it up as. So we got x squared is x and x, positive 14, with a positive 9 in the middle, has to be two positives. So that means that's going to be a positive 2 and a positive 7, because those will add up to 9 and multiply to 14. Let's factor a negative 3 out. So then I'm going to have x squared minus 6x plus 8. Okay, and then I take x squared, it goes into x and x. Positive 8 at the end with a negative sign in the middle means I'm going to have two negative numbers. So that makes it a little bit different for my math, but it's still okay because it's a -4 and a -2. Okay, these multiply to 8, they add up to a -6. Okay, difference of two squares can have a nice little shortcut. Now, technically speaking, this is like x squared plus 0x minus 81. Oops. So if I think of it that way, then I want to still say what multiplies to my -81, but adds to my 0. So the only way this works is if the two numbers are exactly the same. Now what's it called? Our shortcut for this is the difference of two squares. So it's of the form a squared minus b squared. Then it always factors into a minus b, a plus b. So if I look at that, x squared and 81 have to be perfect squares, which they are. So I can do that as x minus 9, x plus 9. Okay. Almost all these are perfect squares as is. So we'll just do those real quick. 9m squared is a perfect square because that is 3m times 3m. -100 is going to be a plus 10 or a minus 10 and a plus 10. That's it. 4a squared, perfect square, perfect square. So 4a squared has to come from 2a and 2a. And -25b squared is going to be a minus 5b and a plus 5b. Because again, think about what does it multiply backwards up to? This is not the difference. It says the difference of two squares. It is a squared minus b squared. So this one is not factorable. So we're going to move on. 2x squared minus 32. They are not perfect squares. However, if I factor a 2 out first, that's x squared minus 16. Now, x squared and 16 are perfect squares. So that'll be x and x. -16 is going to be a plus 4 and a minus 4. Same thing with the next one. I can factor out a 2. So that'll be 4 minus 9n squared. So then I do my factoring here. 4 has to come from a 2 and a 2. Then I got a minus and a plus. And then 9n squared is going to come from 3n times 3n. And that's it there. Okay. All right. Let's look at, we got two more slides. So almost done with this one. So we got factor trinomial when a is no longer 1. There's two methods of doing this. There's a guess and check or what's called the AC method. So I'm going to do both options here, but this one is going to be my guess and check. So this side will be guess and check. This one is going to be A times C method. Okay. So first thing for guess and check is I know it's going to look like this if I could factor it. 2x squared can only come from 2x and x. That's actually nice. I can't do any other number combinations here. Positive 3 here with a negative in the middle. That tells me that I have to have a positive and a negative sign. And one of them is going to be like, basically, I'm going to create a negative 7x in the middle. So I think it's going to do something like this. I think I'm going to have a negative here and a positive here. Because when I distribute this, if I take 2x times this negative number, then x times this positive number, that's good. Oh, wait, I got this wrong. It's a negative and a positive, so it's actually two negatives because negative times negative is a positive. Never mind that. So now I want to look at my factors of 3. It's only 3 and 1, but we got to be careful because what if I put it here and here? Distributing it out would look like this. It would be 2x squared minus 2x minus 3x and then plus 3. This is not my 7x here. So that's where the guessing comes into play and then my checking. So now I have to actually just do this. 2x minus 1 and then x minus 3. If I distribute this out, I get negative 6x, negative 1x, and then I come together as negative 7x. So this is my correct factoring here. The AC method means we're going to take the A value and the C value and multiply them together. So 2 times a negative 7 is a negative 14. Now, if I start thinking about this value here of 13, I want to multiply to a negative 14, but still add to the 13. And that's going to come from a positive 14 and a negative 1. So what that means is I can take my 13 and I can split it up into two numbers. I'm going to do 2x squared plus 14x minus 1x minus 7. These two things are equivalent. All I'm doing is taking the 13 and I'm splitting it up into two other numbers. Now we can do what's called factor by grouping. With two sets of 2 here, I'm going to look for my greatest common factor of both sets. 2x squared and 14x have 2x as its greatest common factor, meaning I'm going to have x plus 7 left over. Negative 1x and negative 7, I like having this as a positive 1x here, so I'll take a negative 1 out of both of these, meaning it turns into x plus 7. Notice how these two are the same. So I'm going to factor again, basically. So x plus 7 could come to the front. 2x minus 1 is going to be left over inside. You could have done this with guess and check. There's only so many options here. AC takes a little bit longer sometimes, but one nice thing about this is this process is always going to be the same. Whereas this process, maybe it's really short, maybe it's really long. It just depends on the problem. Okay. Sometimes it's necessary to factor the GCF out first. So that's what we're going to do next here. So if I'm factoring out the GCF, in this first case, we have 4, 26, and 12. Let's take a 2 out. It'll be 2 times, 2x squared minus 13x plus 6. And I'll do this one as a guess and check. So we got 2x squared has to come from 2x and x. And here's where the guessing and checking might be a little bit longer. With 6, with a positive and a negative, we know it's two negative numbers. But we can also have this be of multiple things. It could be negative 1, negative 6. It could be 6 and negative 1. It could be 2 and negative 3. Or it could be 3 and negative 2. So we have to be careful with that one with our guessing and checking. Because it's a negative 13 in the middle, I think it's going to be a negative 6 here and a negative 1 here. Still check it to make sure it's right, because if I have 2x times negative 6, that's a negative 12x. Negative 1 times x is a negative 1x, and that does get me back to my negative 13x. So guess and check worked okay here, but the AC method might give you like a, I don't know, you're just doing the one process every time, so you don't have to worry about any kind of weirdness with that. Now, I do technically have a GCF here. Factoring is much easier if the front term is a positive number. So what I'm going to do is I'm going to factor out a negative 1. Make it 4x squared minus 12x minus 7 here. This one, again, with the guess and check, if I'm doing guess and check, this might be a little bit harder because this could be a 2x and a 2x. It could also be x and 4x. So I'm just going to do this as an AC to be on the safe side. So A times C is a negative 28 here, 4 times a negative 7. Multiplies negative 27, adds to negative 12. That's going to be 4 and 7, 2 and 14. So it's to be a negative 12 in the middle, that's a negative 14x. So I'm going to have negative 1 times 4x squared minus 14x plus 2x plus 7. Okay, so now I can do this where I look at these two sets here. And I'm going to ignore the negative 1 for now. We'll bring it back later. We've got 4x squared minus 14x. That's going to be a 2x times 2x minus 7. I just realized I made a mistake. That's a negative 7 there, not a positive. Okay. And then 2x minus 7, I can't really take anything out of that, so I'm just going to leave it as a plus 1. And I want to write it this way because I want to make sure this matches up to that. Now that could factor out here, so it'll be 2x minus 7. And then what's left is the 2x plus 1. And that's my factoring. Also, negative 1, technically speaking, I should have done it here. So that's negative 1 is like that. And it carries forward to here. And that is it for our factoring. So we're doing trinomials and GCF. Always look for the GCF first, even if you're dealing with trinomials, just to be on the safe side. All right. That's it for today. Take care, everyone. Oops.